Our first real presentation of the day comes from Professor Srdjan Capkun. I believe many of you in this room already know him well, but a brief introduction nonetheless. So Srdjan is a full professor at ETH. He's been leading the ZISC Center for more than 10 years as its chair. He's a very well-accomplished researcher in the field of system security with well-known results, especially in the domain of wireless security. Today, Srdjan will give us a brief introduction of the ZISC Center and its main achievements. Please.
So thank you, Kari. There will be a lot of thanking going on here during this day, I'm sure. It's somehow habitual to thank all the people involved. There will be a number of pictures that I put on these slides to acknowledge the people who made significant contributions to this center over the years and to the research. And there is probably a large set of people that I clearly forgot to put on these slides. So I would like to thank them first. So to all of those forgotten, thank you so much. And now on to the presentation. So clearly, this is not a surprising slide. 10 minutes of search in your favorite search engine will bring these kind of headlines that from cyber-physical systems to data leaks show you where we are security-wise. And it was really remarkable that in 2003, few people here at ETH and in the industry decided to start this center, right? With some sort of an idea that all of this might happen and even worse things will start happening and that we somehow need to address it. Now, I believe that we are addressing it in a sort of unique way by creating an environment where we can, with direct research, looking at systems, breaking systems, building systems, can address some of these issues, but also, maybe more importantly, by creating an environment where smart people can come, get further educated, inspired, and create spin-offs, go to industry, make an impact there, create products, and address some of these security challenges. And not only address them on the global stage, but also address them here locally in Switzerland, which is happening through a lot of the startup companies that have been started here. And we better make use of that resource that's out there. So Kari already mentioned this. The center was founded in 2003 with David Basin as the founding director. And back then, Uli Maurer and Bernhard Plattner were faculty at ETH involved in security research. And this was a smaller collaboration with a smaller set of partners back then. Since then, it grew to a larger center, right? You will see also the investment from ETH, right? To all these partners, these partner companies that I would really like to thank for their support. It is really not only about the funding that is provided by these companies to the center, but it's about the interactions that we have, which are really remarkable. So a lot of discussions, a lot of stories, a lot of non-security things happened in this center as a result of these collaborations. So we are very grateful to these partners for supporting us. Most recently, Dieter Schwarz Group joined our center with a large donation, as you have probably seen in the news. So again, I'm not going to mention all of the people that we collaborate with from these companies and from, for example, Arma Swiss here, but thank you so much. You know who you are. In terms of ETH also invested in this center heavily. This was also an incredible journey, right, of different hires that happened throughout the years, from Uli Maurer and David Basin, let's say early on, to Adrian Perig and last Shweta Shinde and Florian Tramer. We have an incredible talent here in the center, not only among our core faculty, but also among the faculty that are affiliated with the center that work in security in one way or another outside of their, let's say, core domains of expertise. And maybe most importantly, the center brings together over 100 PhD students, postdoctoral researchers that work on almost any topic in information security that you can imagine. I think this makes it one of the largest and one of the most significant centers in information security today. Now, clearly I chose, so in order to demonstrate that we are not only a large center, but we are also an excellent center, I pulled out a ranking that I fine-tuned to put us on the top as number one, and show the number of publications that we produce. This is, of course, conventional academic output. Whether we are number one or number five, I don't think it matters. What matters is essentially that we are one of the most recognized security centers globally, and I'm not going to be modest here. I think we have remarkable people working in this center, impacting a lot of topics. And I will try to go through some of the results and some of the things that you might find interesting. Some of you might have heard of individual results, but I think it's good to have an overview to show you what's happening at ETH in security. So we first break things, and that's of course fun. I mean, every kid likes to break things, putting them back together, maybe not as much, but we do try to break things. In terms of data, the group of Kenny Patterson has been instrumental in analyzing messengers, communication systems, systems that store data, so data at rest, data in transit, and also systems where data is under computation, and broke a whole range of commercial systems demonstrating that careful designs are still very much a needed skill that needs to be learned and where people need to be educated. Now, of course, all of these things are done through responsible disclosure processes, making sure that harm is not done. But this is a very important public service that we do as a center in order to make sure that our overall security posture is improved over time. Right? Some examples of this was a result by Kenny's group looking into Threema, which is a communication platform used in the Swiss government, or storage systems like Mega. Of course, we don't only break those things. We broke also payment systems. David Basin's group analyzed payment systems and found a vulnerability in these systems that allows people to circumvent the PIN protection. Therefore, if someone steals your card, they could execute a payment with an arbitrary amount without using a PIN. That was a large collaboration that they had a couple of years back. We also break into cars, so we can steal your cars by performing relay attacks. This is the work from my group that we did some years ago, where we shown that we can enter and start any car by performing certain types of relay attacks on cars that use convenient passive keyless entry and start systems. We are also breaking AI systems. So Florian Tremer's group is working on analyzing and showing how brittle AI systems are. Essentially, I mean, he will say more about this topic during his talk, so I'm not going to say much more, but how can you play with these systems in order to expose their weaknesses? What can they leak? For example, if they could leak the underlying data that was used in the training, and so forth. We also show how we can track people violating their privacy. So this is a result from a couple of years ago. That shows that we can track people's mobile phones without the help or authorization from an operator, so we can extract unique identifiers of people and track them along, let's say, the city of Zurich or anywhere else for that matter, and essentially associate persistent identities to their locations. But we don't want only to be destructive. We actually also build systems. We are in a business of understanding things and improving things and building systems that have new security features that people have never thought of before. Right? Because security is not only an afterthought that is glued to a system where you put a stamp that you tested something to be secure, whatever secure means, but security systems can bring you new functionality into the society that you didn't have before. So they can enable new functionality. Uli Maurer's group, and I know that this is maybe for some of you who are not familiar with the theory of crypto, maybe not so close, but has been working on ways to construct systems secure by design. So to construct crypto systems secure by design, and this has been a long-standing area of research where he has made world-class results in this space. Dennis Hofheinz's group is now working on systems that can scale up group communication in Messenger, so point-to-point secure message communication is something that one could say it's solved unless you ask Kenny Patterson, who breaks them. But then if you want to scale it up to group communication, you have to make it again secure and efficient, and this is something that Dennis Hofheinz excels in. This talk, of course, would not be complete without mentioning Scion, which is a new internet architecture that replaces what is a vulnerable routing system of BGP, right? So enables, in a nutshell, the users to keep their data within a certain geographic location, to say, my data will never leave this location. The packets will go through a certain set of intermediaries, and crypto aside, which we know that can be, in some cases, broken, we know that if someone doesn't have access to even encrypted data, clearly they have less of an ability to analyze it. This has been a large project. It seems like a kind of child's play of few packets being pushed there instead of there. But it has made a significant impact. It's highly sophisticated and is now deployed within a Swiss healthcare network. So the Swiss healthcare network runs on top of Scion, of this new internet architecture, and also the Swiss finance network. So this is a major success of research that is long-standing and that has turned out to be quite applied and quite impactful, especially in Switzerland. Now, something that might seem a little bit specialized and maybe only for the experts. So state-of-the-art security protocol model checker, right? Tamarin, which is a tool that David Basin's group has been building for over 10 years. It's a remarkable effort because of its impact. Today, it's one of the most used tools in this space. One example, Apple just released a post-quantum messaging protocol, which was analyzed with this tool by David Basin and his collaborator, showing essentially that what we do here really translates, is not only fundamental and intellectually challenging, but also immediately translates into use in the industry. Another example of the use of this tool is going back again to circumventing PIN verification. If you're analyzing 2,000 plus pages of a specification of a protocol, you better have a tool at hand that can help you to analyze this and find vulnerabilities, and this is where Tamarin excels. And of course, after we find vulnerabilities, after we know that we need to use the tools to verify our systems, we can then start building systems with even more interesting features. This is one of our latest results where we are now using ultra-wideband on the modern phones in order to execute payments, meaning we are protecting payments from relay attacks by combining ultra-wideband and EMV, which are essentially payment protocols. It's a very complex setup of complex protocols, as I've shown on the previous slides, thousands of pages of specifications, different types of kernels, complexity of implementations, combining this with the wireless protocol, putting it all together, and in the end, verifying it on many different levels to obtain a system that can execute something as rudimentary as a payment, however, this time securely, unlike the systems that we have today. This is a fantastic example of a collaboration with our partners that we had. So phishing is annoying, and we all know this, right? But it's actually dangerous. Those people, it seems like an old topic, right? Phishing, we all know about phishing. should be somehow prevented, should be somehow detected, but it can have real impact in organizations because top people in organizations can be phished and damage can happen because someone gets access to their accounts. In order to understand this better, we launched this large collaboration with the Swiss Post. Swiss Post is a large and diverse organization. In the end, we were running for over 15 months a study with 14,000 people. We could not have been, this would not have been possible without a collaboration with such a large company. So these are the kinds of projects where we really value the interactions with our partners. And the initiative for this project actually came from the Swiss Post. They initiated this because of the need for such protection. And we managed to test all kinds of interesting things in this project, including how well people can actually detect and report phishing in order to improve the phishing detection systems. Secure positioning, this is a topic that is of long-standing interest in this center, from GNSS spoofing to secure distance measurement. We have been working on this for over multiple years and built real systems like the UWB secure ranging system, where with ETH spin-off, we have started a new standard for secure ranging, which then went through the standardization process, got approved, chips got built, and the chips from this company made it into Volkswagen and Audis of this world to protect against relay attacks and so forth. So the technology that came out of the heads that came together in this center finally made it into products of tomorrow. One project that we are especially proud of is contact tracing. So I guess some of you can go back to those Corona times and can remember how frustrated everyone was. Back then, the collaboration was formed, notably with our colleagues at EPFL, to build a decentralized but privacy-preserving contact tracing system that people could deploy. It was an incredible effort and quite an exciting time for all of us to be able to so quickly build a system that actually performs what it should, meaning complements manual contact tracing and prevents further infections. So I have to say that in the end, this system was adopted by Apple and Google in their contact tracing framework, and within the Swiss context, the Swiss COVID app was built by Ubique, which is also an ETH company started by ETH alumni, and I see some faces in the audience there smiling now, who contributed to this effort. Thank you so much. This was a fantastic collaboration. We are also building new types of security platforms. Believe it or not, but the game of security of individual systems, so computer systems, is not over. New players are on the market, like RISC-V platforms. They need to be secured. Shweta Shinde, one of our recent faculty, has worked on Keystone, which is a framework to build more secure systems, which in the end inspired us all through our mutual discussion to launch another project, which we are now pushing, which is a kind of a dual phone that we call the Plus phone, which can run several worlds that are mutually isolated so that you can keep your data actually private on your phone, that you can really control how you use your phone, who has your data, and so on, which is not the case, unfortunately, today. And will be even worse. It will become even worse with AI. Right? We also push for adoption. So not only that we build our systems, but you must have picked up on that during this part of my talk. We push for adoption, and this adoption happens in many different ways, but notably through spin-off companies and people who make those steps. So this is actually, I would say, quite an impressive set of spin-offs from our department. And these spin-offs that I highlighted here are in security or alumni were part of our center. Not all of them do security. So Doodle, for example, was started by people who were in David Basin's group. Yeah. So I would really like to thank these people for making this extra step. It's a brave step that they made, taking inspiration or technologies that were built that were developed at ETH and pushing it to the next level. And it's quite a remarkable journey. Some of them I know well. 3DB, for example, built a chip that ended up being in the cars. So smallest ultra-wideband silicon area chip with security features, physical layer protections, and so on. And recently got acquired by Infineon, who is now building a base of ultra-wideband research and development here in Zurich, which I think is a remarkable success. To Futurae, who was founded by two of the alumni of ZISC, and Sandra Tobler here, who it's an innovative authentication platform based on adaptive signal-based authentication that made a strong footing here in Switzerland. It's impressive that they have 25 million authentications a month. They protect 5 billion worth of assets. It's an incredible achievement, and the story started here, and I'm very happy that we have such success stories starting in our center. Exeon, again, a company that provides next-generation network detection and response. I'm sure some of the people from these companies are around here. Talk to them, you can hear their stories. This company started by David Gugelman based on his research in ZISC back over 10 years ago. And what I find really remarkable also is that not only do these companies thrive, but they also have impact on local industries here, helping them protect their infrastructure. I think this is absolutely fantastic way of making sure that we remain robust. Anapaya is a company that commercializes Scion. So the commercial deployments of Scion go through Anapaya. And again, large deployments, very complex systems, a remarkable achievement. Thainty is one of the recent spin-offs from ETH, which will allow you to essentially detect forgeries of documents and physical objects, which is currently seems to be a need based on everything that we have seen. But in the end, it's all about the people. So you have seen a number of people mentioned through these slides, but I want to mention a little bit more because it's not because many people from this center ended up working in all these industries, local Swiss industries, global industries, improving their security and making strong contributions. These are highly specialized people, and we are very proud of their achievements. Not only in industry, but this center made also quite a remarkable impact on academia. So the alumni of this center became professors in a number of universities in Europe, as you can see here, and also a number of universities outside of Europe. And we are very proud of their achievements. These are remarkable alumni. We are also pushing for education. As our rector has mentioned, the shortage of skilled labor in information security is here. We are running masters in cybersecurity and a certificate of advanced studies and diploma of advanced studies in cybersecurity. So a master is a conventional master's program, and our certificate of advanced studies and diploma of advanced studies programs are programs for people who are already in industry to bring them up to speed with the latest developments in information security. But we also never forget the kids. So this is a very nice collaboration that we have started with the ABZ, which is the education center in our department, where we collaborate on introducing security concepts in schools. And I would like to thank here Juraj Hromkovic and also Denis Kom for enabling this collaboration. It's really fantastic to be able to also instill a little bit of security awareness from early ages. And with that, if you absolutely would like to see more about ZISC and these minutes that you will never get back in your life were not enough, you wanted to lose more of your life to learning more about ZISC, our webpage is here. I would like to thank you all again. And again, those people that I didn't mention, thank you as well. Thank you for being here and looking forward to the rest of this event.